everyone. Welcome back. Today again we are having one more problem which is called find the duplicate number. This is also a very common and tricky problem which is asked by many fan companies and interviewers just to know that you guys use your uh, kind of intellectual logic to understand if we can use some tricky way to solve this particular problem. So let's read the problem statement. Given an array of integer nums containing n plus 1 integers. So for example, if there is size n equal to 10, then it will be containing n plus 1 integers, like, okay, where each integers is in the range of 1 to n, and that is also like those numbers will again be in the range of the maximum length of the array. So for example, if it is 10, then it will be in the range of 1 to 10, okay, not more than that. uh, there is only one repeated number, and that's why it's called n plus 1, okay. In nums, return this repeated number. You have to find this repeated number, you have to return it. I think it's very simple problem. If you just see, okay, I have an array which has all the elements, I need to return which one single element which is repeated. So we can do it, right, in a simplistic way. I mean, I'm iterating an array. Of course, the brute force, as I always say, that we always have to start with the brute force approach. But uh, when it comes to the implementing the real solution, it's very important for us to know the fact that we are we should always start with something like just discussing taking 1 or 2 minutes just to discuss about the brute force solution. And then when we are done with this discussion, we should code and discuss about this optimized solution, right? And this is where this makes a very good impact, because interviewer in front, they understand that you know thoroughly, you understand the problem thoroughly, and you are moving towards the solution in a constructive approach, right? So I think uh, I need to read a little bit more here, because this is where the problem statements turns into a little tricky. There is only one repeated numbers. Okay, that's pretty much clear. You must solve the problem without modifying the array nums. Okay, so it has been explicitly written that you should not modify the existing array. Okay, and using only constant extra space. So you can only take constant extra space, and that's it. No other thing you can use. So okay, now let me quickly write I would say, let me quickly write a little bit Java code, and then we will see how exactly it's gonna work, right? So going to IntelliJ, create a class. Yeah, so when it comes to the class, so I should start with something called uh, find the duplicate number, okay? So find the duplicate number, which is find duplicate, and here we go. Okay, so find um, the duplicate. So now I will just copy this. So we have here Java class, which is find duplicate. Now I will just copy the description of the problem. As usual, I will write main, and then in the main, I will quickly write my input, logic, output. All right. So this is how it looks like. Now, as I said, we got a problem. We need to start with, let me write quickly the input nums is equals to, let me copy all the elements from here, and this is elements, and then I have to write my logic, which could be integer duplicate is equals to find duplicate, and there I pass my nums array, and that's pretty much all. And then here over here sys out, I would say duplicate number is duplicate. Okay, so this is pretty much all the basic skeleton of the problem solution. Now, when I read the problem, the brute force approach which comes in my mind is that I need to find an array, an element in an array. And the array itself, we know the fact that it has all the elements from 1 to n, where n is the size of the element. So, for example, if you see here 1, 2, 3, 4, 5, this is the 5, the array with size 5. So, elements you should always have in the range like 1 to 5. So, you see here 1, 3, 4, 2, 2. All right. So, what we can do in the brute force approach, what we can do is that, um, of course, finding a duplicate, we can use two nested loops, compare every element with every other element. Like I will start from picking element at index I is equals to 0, and j will compare it with all the remaining elements in the array. If duplicate found, return it. So it's O of n square, two nested loops, and space complexity is O of 1, right? Because we are not taking any space. But I mean, this is of course a solution. S- But it is written here, you must solve the problem without modifying the array nums and using only constant extra space. So I think this solution is good because we are not modifying the array. Uh, but the drawback of the solution is like very inefficient solution when the large arrays, right, are there. And then why? Because when there is the large arrays, then you have kind of introducing quadratic time complexity, okay, when you are using nested loops. So what else we can do? There is a very common or famous algorithm, or you can say technique, when you have to play around situation like this, is called tortoise and hare algorithms. I think everyone know the story of tortoise and hare. So what we will do, we will treat the array as a linked list where the value at index I points to index nums I, right? There must be a cycle because there's a duplicate. And then in next step, when we use this particular tortoise and hare algorithm, we use two pointers. One will be a slow pointer that moves one step at a time, and then the other fast pointer that moves two steps at a time. And then whenever we detect a cycle when slow and fast meet, once a cycle is detected, reset one pointer to start and move both one step at time until they meet again. This meeting point is the duplicate. How? Okay. So let me one more time. Let me explain it one more time. So we are trying to reuse here the uh, tortoise and hare way of finding the solution. Of course, it will be much faster than brute force. It does not require modifying the input array or using any extra X space. That is also for sure. We will not be modifying any array. So, what we will be doing in order to achieve this is that first we have to understand that what is cycle. Okay, what is cycle? What is the loop here? So, when we say a cycle, it means that slow and fast, okay, these two pointers, they are moving with their own speed. Slow pointer is moving at one step at a time, and a fast pointer is moving two steps at a time. So we have to find a point where slow and fast meet. The moment they meet, it means you meet to a point which we can say a cycle point, right? A cycle is detected. And the moment you get that particular point, you just reset one pointer to the start and move both one step at a time until they meet again. And the meeting point is the duplicate. So let me quickly code it here and then we will explain Again, one more time, what I'm trying to achieve here with the slow and fast. So let me quickly create the method, which is find duplicate. And now I will quickly write the code, which is very simple. Int slow is nums of 0. Int fast, which is nums of 0. All right. And then we have to detect cycle. And when we say we detect cycle is when, let's say we just use do, and there we use while slow is not equal to fast. And over here, we say slow equals to nums of slow and fast equals to nums fast. I'll explain you all that. So this is our work. And then we find, sorry, we find the entrance to the cycle. And if we find the entrance, when we are going to find the entrance to the cycle, we say fast is equals to nums of 0. And then a while loop. There again, slow is not equal to fast. And then we copy this. Nums of slow and nums of fast. Yeah. So that is pretty much all. And then we return at the end slow. Okay. So let me explain you everything in very detail. What is this all about? I talked about hare and tortoise and hare algorithm. Okay. How this is going to solve this problem very efficiently. So slow and fast, we set 2 pointers, slow and fast. They both starting at the first element of the array, which is nums in 0, right? So whatever is the first element, they both start from there. Why num 0? That's the question, right? So in this approach, the array is treated as a linked list. I already said, right? Linked list, where each element points to the index specified by its value. So every particular element, it points to the index specified by its value. So let's say at index I, we get 3. So this 3 points to the index specified by its value. So starting at num0 initializes the traversal. Okay, it initializes the traversal from where they have to start. All right. Now, cycle detection, which is very, very important here. Detect cycle. So the slow pointer points, it moves one step at a time. So slow is equal to nums of slow, right? That's why how it is called slow pointer. It follows the next node based on the value at the current index. Then fast pointer, it moves 2 steps. So over here you see that fast pointer moves 2 steps at a time, jumping 2 nodes in the linked list representative, right? Linked list representation. So now, what is the purpose of detecting a cycle in the linked list? That is very important to understand. The purpose here is, why do they meet? Why this slow and fast pointer meet? If there is a duplicate, then there will be a cycle, and the slow and fast pointers will eventually meet inside the cycle. They will meet definitely somewhere in the inside the cycle, right? And then what we have to do, we have to reset fast equals to num0. Why? Because over here, once the cycle is detected, okay, the meeting point of the slow and fast is not necessarily the duplicate number, because the moment the cycle is detected, it is not necessarily the duplicate number. To find the starting point of the cycle, okay, that starting point of the cycle, the duplicate number in itself, okay, we have to reset fast to the beginning of the array. That is nums and 0. Nums 0, okay. And once we do that, now we will get to know. So this logic over here, it gives you where they detect the cycle, which index it detect the cycle, but it is not giving you the duplicate number, because it's not giving you the starting point of the cycle. The starting point of the cycle is the duplicate number. So you need to get the entrance to the cycle, okay. And this is where you set fast again back to the initial uh, element, and then you again do the iteration here and just move same thing inside the move slow pointer one step, move fast pointer one step. In this case, right now you're just moving one step. Purpose, both pointer now move at the same time. The point where they meet is the entrance of the cycle, which corresponds to the duplicate number. Okay, so this is how we get to know. At the end, we're returning slow. Why? Because at this point, both slow and fast point to the entrance of the cycle, which is a duplicate number. So we can return fast also. It's not a problem, because both are working one step at a time. So yeah, that is pretty much all about the solution. So I think you got it. If you have any questions, you can ask me again. The logic is simple. We need to maintain two pointers, slow and you just need to virtually think that two pointers are moving. Uh, we make fast move by two steps, slow move by one step, and then they somewhere in the loop they detect a cycle when slow and fast would not be equal, meaning they will be. This loop will be running till they are not equal, but the moment they are equal, it means there is a cycle. Now we need to find where the cycle starts, right? So that point where the cycle starts will be the duplicate number. So in order to find it, we just push back fast is equals to num 0, and then iterate the loop again, this time making one step at a time for both for the speed, and then returning either fast or slow as the solution. Yeah. So I mean, this is a pretty common problem. If you have a linked list, you can correlate this problem with a linked list as well. And there in the linked list also, you have to move like next dot next for two steps, and then dot next for the one step. And then you also do more or less the same thing. Okay. Uh, so yeah, that is pretty much all when it comes to the solution. I must run this solution first. Duplicate number is 2. What is the answer? Yeah, it's right. Now for this, duplicate number is 3. So the solution perfectly works fine on my IntelliJ. Let me copy this and paste it onto in the LeetCode to see if it accepts all the test cases. Running this. Perfect. It is accepted. Now submitting the solution. Here we go. So the solution is accepted. Okay. So what is the time and space complexity of this solution? So the time complexity, as I said, it will be O of 1. Time complexity would be okay. Time complexity would be O of n. Space complexity would be O of 1. Right. Because we're not taking any space at all. Like these are constant variables. Yeah. So thank you very much. I see you in another video.